In this video, we're going to look at the law of total probability. So the first thing we need to do is recall our rule for conditional probability. And that there says that the probability that A occurs given B has already occurred is equal to the probability of A intersecting B divided by the probability of B. The law of total probability uses the multiplication rule of probability, which is a result of the formula above. So what we're going to do here is we're going to multiply both sides by the probability of B, and you should see that that and that will cancel. And what you'll be left with is this rule, which is the multiplication rule of probability, which says that the probability of A, given that B has already occurred, times the probability of B is equal to the probability of A intersecting B. And this is used to give us the total law of probability. This law allows us to determine the total probability of an event A occurring when there are several distinct events which result in A. So we could have event A could occur given event B has occurred, so that's A intersecting B, or we could have event A occurring given event B has not occurred, which would be A intersecting the complement of B. So up here we could draw a Venn diagram of sorts, where this is entire sample space, and what I'm going to do is I'm just going to divide it a little bit randomly into event B and the complement of B. So over that we have some event A, and that event A could occur given B has occurred, or could occur given B has not occurred. And now the part that I am shading in right now is the probability of A intersecting B. And now we know from our multiplication rule of probability that that is equal to the probability of A given B has occurred times the probability of B. And now over where I'm shading now in the purple is going to be the probability of A intersect the complement of B. And we know from our multiplication rule of probability that that is going to be the probability of A given B has not occurred, or the complement of B, times the probability of the complement of B. So if we add these two things together, we get the total probability of A, because we've got all of A accounted for in those two calculations. So that's where this law here comes from, which says the total probability of A occurring is equal to the probability of A given B times the probability of B plus the probability of A given the complement of B, or B has not occurred, times the probability of the complement of B. And that's just combining the orange from above and adding on to that the purple from above. So that's where that law comes from. So we're going to do an example now where we have Charlie going on a holiday, and when he does, he either travels to the northern hemisphere or the southern hemisphere. He travels to the northern hemisphere 40% of the time, and if he travels to the northern hemisphere, the probability he will go to a coastal city is 45%. However, if he travels to the southern hemisphere, the probability he travels to a coastal city is 75%. So as you can see, whether or not he travels to a coastal city is dependent or influenced by whether he goes to the northern or southern hemisphere. And we are asked, what is the total probability that Charlie will travel to a coastal city on his holidays? So often this is best done by setting up a tree diagram, but you could go straight for the rule if you wanted to. So in this example, we use a tree diagram. So we can have Charlie either travels to the northern hemisphere or the complement, which would be the southern hemisphere. And then if he travels to either of them, he could go to a coastal city or he could not go to a coastal city. Okay, and the same would be true if he didn't go to the northern hemisphere. He could go to a coastal city or not go to a coastal city. Next, we need to consider the probabilities on each of these branches. So here, this is the probability that he travels to the northern hemisphere. And in our question, it says that he travels to the northern hemisphere 40% of the time. So that can be written as 0.4. And then if we keep going along this branch, it says that the probability that he goes to a coastal city given he's gone to the northern hemisphere is equal to 0.45 due to this 45% here, which said that he would travel to coastal city 45% of the time if he travels to the northern hemisphere. That means that the probability of him not going to a coastal city given he went to the northern hemisphere is equal to 0.55. For the bottom of the tree, If he is going to the southern hemisphere, so the complement of the northern hemisphere, that must add up to 1. So we have 0.4 plus 0.6. So there's a 60% chance that he goes to the northern hemisphere in his holidays. And then the probability of him going to a coastal city, given that he is not gone to the northern hemisphere, is 0.75. So that comes from this part of the question here, which means that the probability of him not going to a coastal city, given he didn't go to the northern hemisphere, is equal to 0.25. So the two branches of the tree that result in him going to a coastal city, he could go to the northern hemisphere and then go to a coastal city, or he could go to the southern hemisphere followed by a coastal city. So the probability of him going along this top branch is equal to the probability that he goes to a coastal city given he's gone to the northern hemisphere times the probability he's gone to the northern hemisphere, which is equal to 0.45 times 0.4. And if you do that calculation on a calculator or you do it in your head, you find it's 0.18. And then going along the bottom, if he goes to a coastal city given he went to the southern hemisphere, and we times that by the probability that he goes to the southern hemisphere, that's going to be equal to 0.75 times 0.6, which is going to be equal to 0.45. Therefore, the total probability of him going to a coastal city is equal to this value here plus this value here. So we have 0.18 plus 0.45. And that in total gives a 0.63 probability that on any given holiday, he will end up at a coastal city. After this video, you should be able to understand how the law of total probability was developed or derived, use a tree diagram to determine the total probability of an event occurring, or you could use the law straight out to determine the total probability of an event occurring.